Indicators. Indicators are those pigments which change their color or smell in acidic or basic medium. Natural indicators. Litmus, turmeric, red cabbage. Man-made indicators. Phenolphthalein, methyl orange. Olfactory indicators. Onion, vanilla. Acid. Acids are sour in taste. Turn blue litmus to red. Dissolve in water to release H+ ions. Their pH value less than 7. CO2, SO2, NO2 are acidic gases which produce acid rain. Acid solution conducts electricity. Chemical properties of acids. Number 1. Reaction with metals. Acids give hydrogen gas along with respective salt when they react with metal. Some of reactions examples are as follows. Test for hydrogen gas. The gas evolved after reaction of acid with metal can be tested by bringing a lighted candle near it. If the gas bums with a pop sound, then it confirms the evolution of hydrogen gas. Burning with pop sound is the characteristic test for hydrogen gas. Number 2. Reaction with metal carbonate and metal hydrogen carbonate. Acids give carbon dioxide gas and respective salts along with water when they react with metal carbonate. And that same kind of reaction follows when they react with hydrogen carbonate, which is also called bicarbonate. Test for evolution of carbon dioxide gas. When carbon dioxide evolved from the reaction, if we passed it through from lime water, it turns milky because of the formation of a white precipitate of calcium carbonate. But when excess of carbon dioxide passed through lime water, it makes milky color of lime water disappear. This happens because of formation of calcium hydrogen carbonate. Strong acids. An acid which is completely ionized in water and produces H and is called strong acid. Example: hydrochloric acid, HCl. Sulfuric acid, H2SO4. Nitric acid, HNO3. Carbonic acid, H2CO3. Phosphoric acid, H3PO4. Weak acid. An acid which partially ionized in water and thus produces a small amount of hydrogen ions H+ is called the weak acid. Example with their sources: acetic acid vinegar, ascorbic acid guava, amla, citric acid lemon and other citrus fruits, lactic acid sour milk, curd, methanoic acid ant sting, oxalic acid tomato, tartaric acid tamarind. Bases. Bitter in taste. Turn red litmus to blue. Release OH- ions in aqueous solution. Their pH value greater than 7. Soapy to touch. Conducts electricity in solution. Chemical properties of bases. Number 1. Reaction with metals. When alkali, base, reacts with metal, it produces salt and hydrogen gas. Example: sodium hydroxide gives hydrogen gas and sodium zincate when reacts with zinc metal. Next, sodium aluminate and hydrogen gas are formed when sodium hydroxide reacts with aluminium metal. Number 2. Reaction with oxide of nonmetals. When base reacts with non-metal oxide, both neutralize each other, resulting respective salt and water. Example: sodium hydroxide gives sodium carbonate and water when it reacts with carbon dioxide. Next, calcium hydroxide gives calcium carbonate and water when it reacts with carbon dioxide. Number 3. Neutralization reaction. An acid neutralizes a base when they react with each other and respective salt and water are formed. Example: sodium chloride and water are formed when hydrochloric acid reacts with sodium hydroxide, base. In a similar way, calcium chloride is formed along with water when hydrochloric acid reacts with calcium hydroxide, base. Number 4. Reaction of acid with metal oxides. Metal oxides are basic in nature. Thus, when an acid reacts with a metal oxide, both neutralize each other and respective salt and water formed. Example: calcium oxide is a metallic oxide which is basic in nature, reacts with hydrochloric acid. Neutralization reaction takes place and calcium chloride along with water is formed. Similarly, sulfuric acid reacts with zinc oxide, then zinc sulfate and water are formed. Dilution of acid and bases. The concentration of hydrogen ion in an acid and hydroxide ion in a base, per unit volume, shows the concentration of acid or base. By mixing of acid to water, the concentration of hydrogen ion per unit volume decrease. Similarly, by addition of base to water, the concentration of hydroxide ion per unit volume decrease. This process of addition of acid or base to water is called dilution, and the acid or base is called diluted. The dilution of acid or base is exothermic. Thus, acid or base is always added to water and water is never added to acid or base. If water is added to a concentrate acid or base, a lot of heat is generated, which may cause splashing out of acid or base and may cause server damage, as concentrated acid and base are highly corrosive. Strength of acid or base. Acids in which complete dissociation of hydrogen ion takes place are called strong acids. Similarly, bases in which complete dissociation of hydroxide ion takes place are called strong bases. In mineral acid, such as hydrochloric acid, sulfuric acid, nitric acid, etc., hydrogen ion dissociates completely and hence, they are considered as strong acids. Since inorganic acids' hydrogen ions do not dissociate completely, so they are weak acids. For water or neutral solutions, pH 7. For acidic solutions, pH less than 7. For basic solution, pH greater than 7. Importance of pH in our daily life. Importance of pH in our digestive system. Our stomach produces hydrochloric acid. This dilute hydrochloric acid help in digestion of food. In case of indigestion, our stomach produces acid in a very large quantity, because of which we feel pain and irritation in our stomach, acidity. To get relief from this pain, antacids are used. These antacids neutralize the excess acid because they are basic in nature and we get relief. pH of acid rain. When pH of rainwater is less than 5.6, it is called acid rain. Flow of acidic rain in water bodies makes them acidic, causing a threat to the survival of aquatic life. It also results in damage of structures made with marble like Taj Mahal. pH of soil. Plants require a specific range of pH for their healthy growth. If pH of soil of any particular place is less or more than normal, then the farmers add suitable chemicals to it. The addition of these chemicals of presences of excessive damage the nutrients of the soil and decrease its natural fertility. Salts. Mostly salts are solid. High electrostatic force of attraction between ions. Mostly salts are water-soluble. Their melting point and boiling point generally high. Their aqueous solution good conductor of electricity. Family of salts. Salts having the same cation or anion belong to the same family. For example, NaCl, KCl, LeCl. pH of salts. A salt of a strong acid and a strong base will be neutral in nature. pH equals 7, approximate. A salt of a weak acid and a strong base will be basic in nature. pH greater than 7. A salt of a strong acid and a weak base will be acidic in nature. pH less than 7. The pH of a salt of a weak acid and a weak base is determined by conducting a pH test. Sodium hydroxide. Chemical formula NaOH. Also known as caustic soda. Preparation, chloralkali process. Electrolysis of brine, solution of common salt, NaCl, is carried out. At anode, Cl2 is released. At cathode, H2 is released. Sodium hydroxide remains in the solution. Bleaching powder. Chemical formula Ca, OCl, Cl or CaOCl2. Preparation Ca, O, 2 plus Cl2 Cocl 2 plus H2O. On interaction with water, bleaching powder releases chlorine, which is responsible for bleaching action. Baking soda. Chemical name sodium hydrogen carbonate. Chemical formula NaHCO3. Preparation, Solvay process. A. Limestone is heated, CaCO3 CaO plus CO2. B. CO_2 is passed through a concentrated solution of sodium chloride and ammonia. NaCl plus NH3 plus CO2 plus H2O NaHCO3 plus NH4Cl. Uses 1. Textile industry. 2. Paper industry. 3. Disinfectant. Washing soda. Chemical name sodium hydrogen carbonate. Chemical formula NaHCO3. Preparation, Solvay process. A. Limestone is heated, CaCO3 CaO plus CO2. B. CO2 is passed through a concentrated solution of sodium chloride and ammonia. NaCl plus NH3 plus CO2 plus H2O NaHCO3 plus NH4Cl. Uses 1. In glass, soap, and paper industries. 2. Softening of water. 3. Domestic cleaner. Plaster of Paris. Gypsum, CaSO4.2H2O on heating at 100 degrees Celsius, 373 Kelvin, gives CaSO4. 1/2 H2O and 3/2 H2O. CaSO4. 1/2 H2O is plaster of Paris. CaSO4. 1/2 H2O means 2 formula units of CaSO4 share 1 molecule of water. Uses cast for healing fractures.